Okay, so the recording has begun. This is day 2, week 5 of our journey together, and it's definitely a delight to have each and every one of you here for this discussion and for this class. Um, like I started out by saying earlier, we're going to be doing one of my favorite topics of mathematics. Um, even though um, it can be challenging, and I admit that it can be challenging, but it is a good topic nonetheless. Talking about none other than probability. Anyone have ever done probability before? Anyone have ever done probability before? No one? I know true. I don't believe that. Has any of you ever done probability before?
Uh,
Yes,
my
sir.
teacher never taught it, but I went over it for the Bgcse by
Oh,
myself.
okay. So you're exposed to it. All right.
Sort of.
So you're exposed to it at least. Say. Hello?
I mean, sort of.
Sort of. Okay. Sort of. All right. All right. So we're gonna be doing probability in a weird way. Um, um, Obviously there's a basic idea of probability. Um, you basically look at the numerator and the denominator, and because probability basically is a fraction, when it comes down to it, that's essentially what it is. But we're basically going to set a foundation for our discussion on probability, really go through it step by step by step by step. I don't know if we are even going to be able to say do a actual probability question, say, um, but I'm sure that we'll be able to. Um, I'm sure we'll be able to get into those, at least have some initial discussions on, things that are important when we look at the whole topic of probability. It's a good question. Um, so let me. Today is what? Today is Tuesday. Tuesday the. Let me head up properly. Tuesday the 2nd of August. Would you believe it? The 2nd of August, 2022. The subject is obviously mathematics. We are going to do mathematics and English today. And the topic is going to be, well, we can definitely have to do it, write it like this. The theme is probability. That's what we're gonna basically be talking about. But the specific topic for today is going to be we're going to be talking about sample spaces and events. All right, and this is probably just going to be part 1, all right, of our discussion on sample spaces and events. So I guess we could start off with some initial, with just basically an introduction, say, right? So when we really look at it, right? Why even learn probability, and what is the benefit of knowing it, and why do we, like, where do we find this in real life? So let's ask probably a question that would run through someone's mind in a real life scenario, say, one question that would arise in real life that involves probability would be what? Think about a question, Sierra. What question you think would arise in real life that someone would say, you know what, I need to, what's the probability of doing that? Like, what question you think an
They would
adult?
ask what is probability.
Say it again.
They probably would ask what is probability
You probably ask what's probability. I'm talking about
or
like
what comes under it.
what comes under it. Um, I mean, like in general practice, like what would I say? What would I want the probability of? Say,
What is the main reason for probability?
okay, that's a good try. Deja, what do you think? What do you think I would want the probability of?
Probably if you're gambling, you probably want to know the probability of your number falling or something.
Exactly, exactly. That's typical. That's typical Bahamian, you know, um, adult, question. Like, what is the probability, right? What is the probability of winning the lottery? Let's say twice, right? And Deshaun, what you think the probability of that is? The probability of winning the lottery twice.
Um, I don't know.
You don't know? Why? Why? If you didn't, anyone know? Because if you do know, that's some valuable information.
1:2
1:2. So you actually
or
do know?
0:2?
Okay, 0:2. Okay, so she said it's 0:2. Well, if you know that, then you could work for Idle Luck. CPC work for Idle Luck then, or you could be my secretary, and tell me what number gonna fall then. So we can get in this job party. I just put your leg, but it's something that it's questions like these that often um in consideration. What's the probability of winning the lottery twice or even once? Sorry, let me put this here. Um, let me adjust this. And I'm gonna. All right. I think this is the one. Yeah. The next question would be say. I mean, I am not for gambling, but I'm just saying that would be a question. Another question that would fall under this would be like, what are the chances? So that's another way to put to deal with probability. What are the chances? That's another way to say it. So what are the chances that a college athlete whose drug test, spell that wrong, whose drug test is positive for steroid use is actually using steroids, right? This is an interesting question. Because go ahead.
You mean as probability as in like 50% chances and all that stuff?
Yeah, something like that. Likelihood. What is the likelihood of something to happen? What is the chances of something to happen? Right? How likely is it to happen? Right? So this is an interesting question. What is the likelihood of a person who tests positive, right? Who tests positive for steroids? What's the probability that they're actually using steroids? Now, the reason why that's an important question is because, wait, give me one moment. Oh my.
Question, y'all talking about soccer?
Yeah.
Y'all asking like how they begin the game?
Yeah. How do they begin the game? Yeah.
It's either you flip a coin or rock paper scissors.
Exactly. Okay. So it's like very good. I like that hearing that from you. The soccer girl, right? One moment. All right. Okay. So at the beginning of a football game, to ensure fairness, like Miss Rashan told us adequately, we have a coin toss, right? So I am so sorry that these wasn't recorded, but because the recording just started again recently, so I just want to show this notes just to know that we was doing this before. So if you're watching the recording afterwards, know that these are part of the notes that we did. I'm so sorry that it wasn't being recorded at that time, but we are actually on sample spaces and events right now, so sorry about that. But at the beginning of a football game, to ensure fairness, the referee tosses a coin. Okay, so we'd say the referee tosses the coin, and you may be like, well, what does this have anything to do with probability? Well, you'll see. To decide who will get the ball first, right? Now when the referee, right, tosses the coin and observes which side faces up, there are how many possible results? So when he flipped that coin, what are the possible results that he's going to get?
Heads or tails?
Heads or tails? Very good. So there are two possible results, right? Two possible results. So either you're going to get heads, which we would denote as capital H, or you're going to get tails, which you're going to denote with a capital T. These are the only possible results. Ignoring the now when I say these are the only possible results, obviously I'm ignoring the fact that the coin could land straight up on not touching any side, but we're gonna ignore that for now. All right, so ignoring rare results, right? So you're either gonna get heads or tails. Okay, so what does this have to do with probability? Well, the act, right, the act of tossing the coin, right? The act of tossing the coin is an example of an experiment, and that's going to come up again and again with these things. This is an example of an experiment. Very keyword in probability. Experiment, that's one keyword, so underline that for me. The two possible results which is what? Heads and what? Tails, H and T, are what we call possible outcomes. So outcomes is another keyword in probability. So experiment is a keyword in probability, and outcomes is a keyword in probability. So the act of flipping that coin is what we call an experiment. The two possible results are going to be the possible outcomes of the experiment, okay, of the experiment, and the set, capital S, which contains One more. Sorry, and so the act of tossing the coin is going to be an experiment. The possible results, or what we call the we call that the outcomes. All right. So there's two things we have so far. We have experiment, which is him flipping that coin. That's the experiment, right? We have the outcomes of the experiment, which is the possible results. So the outcomes. So outcomes and experiments. Experiment is flipping the coin, right? Outcomes is going to be the possible results, which are going to be the heads and the tails. And the set, which contains the outcomes, right? So the set S, which contains the outcomes. Anyone have ever done sets before? Anyone have ever done sets before? Don't be shy. This ain't the time to be shy. Anyone did sets before? Maybe my mic is muted. All right, hello. Can y'all hear me? Hello, can y'all hear me?
Yes.
Okay,
Yes,
sorry.
sir.
My apologies. I was explaining and I didn't even realize I was unmuted. Yeah, so the experiment is going to be actually flipping that coin. The possible results is going to be the outcomes. And the set, anyone ever did sets before? Sets. Me. Okay, Jasmine says me. And the set, anyone else did sets?
I've done it.
Okay, good. So, and the set containing, which contains, I really want to put it inside there. So capital S equals, just look more fancy. So, and the set S, which contains the possible outcomes, is called the sample space. All right. So the set S, of all, right, of all possible, say outcomes, is the sample space. Okay, that's the sample space for the experiment. Good. So that's what we mean. So keywords, experiment, that is going to be, experiment is going to be, what should I say? That's going to be the act of flipping that coin, right? The possible results are going to be your outcomes. It's either going to be head or tails. And the set that contains your possible outcomes, which is heads or tails, that set is going to be the sample space. Okay? So 3 keywords: experiment, outcomes, and sample space. All these 3 words have everything to do with probability. Okay? Okay, so any questions before we actually continue? Any questions? No questions? No questions from no one? Don't be shy. If you don't understand something, let me know. All right. Good. So, all right. So let's actually define. I guess that we're good then, since no one is saying anything. So, I guess we're good. So, here we're gonna have the definition. So experiments. Remember our keywords now: experiments, outcomes. Yeah, outcomes. Very good. All right. Okay, Jasmine, go right ahead. Outcomes and sample space. Very good. Those are our keywords. So we're gonna actually provide a definition for them. So far, all we have done is give it in terms of the, we give it in terms of the example. But what do we actually mean by those words? Experiment, outcomes, and sample space. Like, what is the exact definition of that? Okay. So let's actually look at a concrete, say, definition. So let's look at I think we could add a little color to this with a little underlining. And let's put a nice color on it, say blue. Nah, don't like it. So let's look at something nice. Shape outline. Red, yeah, that stands out. And then that's more like it. Okay, good. So definition. So an experiment. An experiment is an occurrence with a result, or another word for result is going to be outcome that is uncertain before the experiment takes place. All right. That's what we mean by an experiment. So in the mathematics, we're not talking about in science or something like that. We're talking about in mathematics. So and when we're talking about probability. So in the world of probability, when we say an experiment, we mean an event or a happening in which the result or the outcome you don't know before you do the experiment, right? You just don't know. So give me an example of an experiment. So examples. Now remember, for an example of an experiment, remember you do not know what the outcome is going to be before you actually, well, before I even go to examples, let's not do that. Should I not? Yeah, let's go to examples. So I think that's appropriate. Yeah. So give me an example of an experiment CRO. Like, remember, you don't know what the outcome is before the result happens, or before the occurrence happens. Like, you don't know what the result is going to be. So I mean by experiment.
I mean, like 0 to 2?
No, I mean like an occurrence. For example, let me give you an example. So for example, tossing a fair coin, right? Like, that's an experiment. Would you agree?
It is.
Because we don't know what our result is going to be before.
What the chances?
Yeah, we don't know if it's going to hit heads or tails before we toss the coin. You see what I'm saying? Give me another example, Deja, of a experiment.
Rock, paper, scissors.
Rock, paper, scissors, shoe. Okay, yeah, I like that because we don't know what's going to be the outcome, so who's going to win. So rock, paper, scissors, game. Spell that wrong. About rolling a fair die. Everyone know what I mean by die, right? Let's say die.
Like the dice?
A dice, yeah. So rolling a dice, right? I mean, really, dice is. You shouldn't really say dice because dice is it's plural, you know. Um, Technically speaking, dice is plural, but you know, we could use dice because um, in modern standard English, it could be singular or plural. That's a strange thing. But in your exam, they would say die. They typically say die, D-I-E, to represent one, and dice to represent two. That's typically the case. But say it again.
You said they would use die for representing one.
Yeah, they'd say rolling a fair die. So a die or dice, whatever one they use, you know, they're talking about a dice. Okay. Um. So if you throw a fair die or fair dice, that's also a random things or an experiment. So for example, what else if I could say if I'm dealing a deck of cards, right? Before I deal the deck, right, or give out the cards, I don't know who's gonna get, at least in a fair game, right? We saying that everything is fair, right? That means everybody um that it's truly fair. Nobody know beforehand. So if I deal with you, say 3 cards or 5 cards, I don't know what you get, right? You don't know what I get. Say it's random, like nobody knows, right? We don't know who going to get what before we deal the deck of cards. You see what I'm saying? Do you understand what I'm saying?
Yes, sir.
So that's what we mean
Yes.
by an experiment. So rolling a fair coin, rolling a fair dice, dealing a deck of cards, those things are experiments because we don't know what the result is going to be before we do the experiment. And so then there's that. Okay, now that's experiment. Now we're going to talk about an outcome. Now I'll talk about sample space. So what we mean by sample space is okay, sample space. I know this is more notes than usual, but bear with your math teacher. This is not language, but we still need to have notes. All right, so bear with me as I give you these notes for the subject. Okay, so the set, and this is very important, it's a set. All right, and when we say set, this is very important. This is very important. When we're talking about sample space, the set, or we say group, right? The set or the group of all, and this is very important, I need to put this in highlight, all possible outcomes, right, is called the sample space, all right, for the experiment. Okay. So, for example, so if for example, if my experiment, right, is that I am going to flip a coin. I mean, no, we need a fair coin. flip a fair coin and observe the side facing up. Good, good. When I flip this fair coin, Miss Johnson, what is going to be my outcomes when I flip this fair coin? It's going to be my outcomes. Hello, Miss Johnson, are you there?
Yes, sir.
Yes, what's going to be my outcomes when I flip this fair coin?
Will it be 2 out of 2?
Not 2 out of 2. What are the sides on the coin? You have what?
Head and tail.
Heads and tails. Very good. So my outcomes is going to be heads, capital H for heads, and capital T for tails. Now, this one is for, say, Deja. So what is going to be my sample space? Let's go, Deja. What's going to be my sample space?
So you're saying that you want me to put it like, how do you do it for the set?
Yeah, set notation is important with this.
Okay, so I guess you put S, because I saw you do it before. So I guess you put S on the outside, equals, and then you put the bracket, and then you put H and T on the inside.
Very good. So my sample space is going to contain H and T. So my question also is like, what is going to be, because it's going to become important in our discussion, even though I didn't say it yet, but what's going to be, say, the number of elements in my sample space. So what's going to be the number of elements in my sample space? So number of elements in the sample space. Now, when we say number of elements in the sample space, what we mean is, or how we denote it is, or the representation or the sign that we use for number of elements in the sample space is going to be it's going to be n of capital S. Okay, that's the sign that we use, because capital S is it's your sample space. So I'm trying to say, how much elements do I have in my sample space right here? So Jasmine, how much elements do I have in my sample space?
2.
2. Very good. I only have 2, which is heads and tails. Okay, so my experiment is flipping a fair coin, because it's an experiment, because I don't know what's going to be the result when I do that. My sample space is going to be sorry, my outcomes is going to be heads or tails. My sample space is going to be the set, basically just putting this in curly brackets, the set that contains the outcomes, and then the number of elements in my sample space, which I write as n of s, is going to be 2, because there are only 2 elements in my sample space. Okay, good. Does that make sense?
Kind
Kinda. Kinda. All right. Kinda. What don't you understand?
So like, what if like we have the different dices or something else.
Okay, yeah, that's a nice question. So what if we change the experiment, right? So what if we change the experiment? That could happen. So let me give you another example. If we say, if we were to change the experiment, right? So if we were to change the experiment, then we know that something else is going to happen. So, um, so let's change the experiment. And the experiment is, let's say in this one, in this experiment, we want to roll, right? Let's say we want to roll a fair dice and observe the numbers facing up. Okay, so we're going to roll a fair dice and observe the numbers facing up. Good. Good. Deshaun, what would be the outcomes of this experiment? And I have a dice. Hopefully you all know what a dice look like. Let me make an attempt to show you what a dice look like. You have a dice, and you want to roll this dice. What's going to be the outcomes of this experiment if you roll in this dice? It's going to be the outcomes, Deshaun.
They'll fall on the one, I guess.
Say it again?
I'm not too sure. I don't really understand it.
You don't really understand it, okay. But think about it. What is one of the possible numbers that your dice could fall on?
Six.
Say it again?
6.
6,
Six.
good. That could happen. What else it could fall on?
Oh,
Uh-huh.
3.
3, yes, it could fall on 3.
yes.
What else it could
fall
fall
on
on? 2, yes, it
two.
could fall on 2. What else could it fall on?
I see 1.
1,
Four.
yes. Yeah, 4. What else?
5.
5. Very good. So your outcomes is going to be 1, 2, 3, 4, 5, and 6 because that's what your dice could fall on, right? When you roll it, it could either fall on 1, 2, 3, 4, 5, or 6. Do we agree?
So,
Okay, good. Now, this is gonna be an interesting one now. So Sierra, what's gonna be my sample space?
A possibility of 1 to 6.
The set that contains what?
1 to 6.
1 to 6, very good. 1, 2, 3, 4, 5, and 6. So basically what all the sample space is taking your outcomes and putting them inside a set. Okay. Now, this question is for Rashan. What is going to be the number of elements in my sample space?
I know.
Rashan, go ahead, Rashan. What's going to be the number of elements in my sample space? Hello, Rashan. Are you there? All right, go ahead. Someone who said they know.
6.
6. Very good. 6. All right, good. So the number of elements in my sample space is going to be, remember this is how we write it. number of elements in the sample space is going to be 6, because if we count 1, 2, 3, 4, 5, 6 numbers in our sample space. Okay. All right. Question: Have anyone ever learned this before? Experiment, outcome, sample space, number of elements in the sample space.
No, sir.
No, sir.
No. Okay. Deja, you ever passed through
No,
this?
sir.
No. Okay. How about you, Miss Johnson? Ever learned about the experiment, outcome, sample space, number of events, number of elements in the sample space? I guess that's a no. Okay, so but that's one thing about probability, right? Probability, like, we could use so much examples. So, and the examples are important for us. So, let's continue with our other examples. So, so let's say the experiment is that you want to give me one moment. Let's say that the letter is, let's say not the letter, but let's say that the experiment is choosing at random. Is very important. Does it have to be random? Choosing at random a vowel, let's say a letter, because that's from the word Mozart. Say. So I hate to use the word Mozart. So let's say encyclopedia. Someone help me spell encyclopedia. Let me see if y'all got it. I spell encyclopedia. This is a typical question.
Pardon?
Well, that's not use encyclopedia. Yes, let's use education. Say. So it's gonna be what? EDUCATION. I hope there's no repeats in this. E, there's no E, there's D, there's no other D, U, C, A, T. Good. Yeah, good. I like this word. So choosing a letter at random from the word education. Let's say that's your experiment, right? Good. What are gonna be your outcomes? So let's say that you have to pick a letter from the word education. I don't want this to be capital. Let's use small e. And what's going to be your possible letters that you could choose, or that you're going to be able to choose? Or that's going to be your options. You could choose E. What else could you choose?
U.
How about D? D with nerdy. U. What else?
C.
C. Very good. A. T. What else?
I.
I. Very good. What else?
O.
O. And what else?
N.
And N, right? Good. So that's gonna be my outcomes. My outcomes is gonna be all of the letters that I could choose from this word. So if I would have all these letters inside a bag, say, and I close my eyes and I pick in a letter from that bag, I could choose an E, I could choose a D, I could choose a U, I could choose a C, I could choose an A, I could choose a T, I could choose an I could choose an O or an N. All of them are up for grabs, right? Um, but my question is, what is going to be my sample space? And my sample space, I'm going to ask, Sierra, what's going to be in my sample space then?
Sample space is going to be S
Mm-hmm.
equals
Mm-hmm.
E
Mm-hmm.
D
Mm-hmm.
U
Mm-hmm.
CATION.
Mm-hmm. Very good. So my sample space is going to contain all the letters from the word education. Good. Now, what's going to be Albernic, the number of elements in my sample space?
It would be 9.
9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Very good. It's going to be 9. Very good. So number of elements in my sample space is going to be equal to 9. Excellent. Good. So hopefully you're getting a gist of this, right? You have an experiment, you have your outcomes, you have your sample space, and you have your number of elements in the sample space.
I have a question.
Mm-hmm.
What if you have a tree?
You way ahead with your tree, way ahead. That's possible. When you deal with we'll discuss it when we dealing with probability tree, but we are far from
Yeah, because
probability tree.
I saw that a lot in the past papers. I was so
Mm-hmm.
lost.
Yeah, probability tree. It's not hard. Probability tree is not hard. So that's fine. So there's also another experiment that we could look at. So the reason why I'm doing so much experiments is because it's so much questions that we could ask you based on these things, and and um and the only way, not the only way, but the best way of seeing to deal with these is to show students the examples beforehand, because I've learned that if I do it and don't give you the examples, well, you know, you don't really get it, because it's not an easy topic to think about because it's new, you know. Probability have us thinking more than we probably would. So I'm going to give you the examples, and then the reason why I give you so much examples is so that it's because I I want to I want to train your mind to see the question, so that when I actually give you a question, which I will, you'll be able to say, oh, well, sure, just like that example, you know. So that's why I'm giving you a good range of examples so that you could be able to choose from. So let's say you want to do choosing a whole number from 1 to 10. Okay, so we're choosing a whole number from 1 to 10, and choosing at random. So choosing at random, a whole number from 1 to 10. Okay, good. So the question is, this one is for Dylan. What will be my outcomes, Dylan?
Uh, 1,
1. Very good.
2,
2. Very good.
3,
3.
4,
Mm-hmm.
5,
Mm-hmm.
6,
Mm-hmm.
7,
Yes, sir.
8,
8.
9,
Yes, sir. Say it with pride.
and 10.
Yes, sir. Good.
And this is to Sean. 'Cause Dylan wasn't here.
Oh. Wow. Yeah, remind me of Jacob and Esau. How Isaac got swing into thinking that Jacob was actually Esau. Interestingly enough, my name is Isaac, so I got swing again. All right, sample space. So sample space. Who is gonna be brave enough to answer sample space?
Me.
All right. Jasmine, never, oh, ever ready for a challenge. I like that. Good. What is the sample space?
Um, 1,
1. Yeah.
2,
2.
3,
Yes, sir.
4,
4. 5. Yes, sir.
6,
Uh-huh.
7,
Uh-huh.
8,
Mm-hmm.
9,
Uh-huh.
10.
And 10. Very good. Um, what's gonna be the number of elements in my sample space? Rashan. What happened to Rashan these days? Hello, Rashan. Where are you? The number of elements in my sample space. All right. You could go ahead, Jasmine, because I don't think she's out.
It's 10.
It's 10. Very good. 1, 2. Yes, 10. Good. All right. So choosing at random a whole number from 1 to 10. That's that. All right. So I wonder if there is. All right. Good. So I think that we have the gist of what's going on. And so with that being said, I want to let's actually get into the exercises, right? So let's go, let's begin. So I wonder if I should do it on PowerPoint or should I do it on, yeah, let's do it on PowerPoint. Yeah. So exercises. So in each case, or for each experiment, for each given experiment, state the outcomes, sample space, and number of elements in the sample space. So each, for whatever experiment I give you, I want you to tell me what's going to be the outcomes, what's going to be the sample space, which is going to be the number of elements in the sample space. So the first one is going to be your experiment is number 1 is tossing an unweighted coin. Second experiment is casting an unweighted dice and observing the numbers faced up. The third experiment would be what if we want to choosing at random letters from the word at random, a letter from the word calendar. All right. Number 4 experiment, choosing at random a whole number from 1 to 8. Next experiment is choosing at random a prime number from 2 to 17. Experiment choosing at random, or we'd say a bag contains 4 fruits. If I say choosing a fruit, choosing at random a fruit from a bag that contains a pear, apple, apple, orange, banana, peach, and mango. All right, good. I think 6 is enough. All right, so those are gonna be our questions. I'm gonna give you 2 minutes to tackle them, and the timer is about to begin. Let me get it started. The timer has begun. So for each given experiment, state the outcomes. So tell me what the outcomes is going to be, what the sample space is going to be, what the number of elements in the sample space is going to be. So what happens when I toss an unweighted coin? What's going to be my outcomes, experiment, number of elements in the sample space and sample space. When I cast an unweighted dice and observe the numbers facing up, what's going to be my outcomes, sample space, number of elements in sample space. When I choose at random a letter from the word calendar, what's going to be no, I can't use that word calendar. Sorry, I can't use that word calendar. That's too tricky. Sorry, we can't use that word calendar. Sorry. Let's say Caleb. Caleb is better. So choosing at random a letter from the word Caleb, not calendar. Calendar is too tricky. We haven't done that yet. Number 4, choosing at random a whole number from 1 to 8. Choosing at random a prime number from 2 to 17. Choosing at random a fruit from a bag that contains a pear, an apple, an orange, a banana, a peach, and a mango. What's going to be my outcome, sample space, and number of elements in the sample space? And we're almost done. Alright, so the timer has expired. Alright, so let's begin with our unweighted coin. So let's begin with that. So okay, with the unweighted coin, let's go with Albanic. How are we gonna do this? What's gonna be my outcomes for the unweighted coin?
H and T for heads and tails.
H and T for heads and tails. Now, does anyone know what I mean by unweighted?
Like on the app, mobile.
No. When I say unweighted, what do I mean? Because that's important to understanding the question. So when I say unweighted coin, it means a coin that doesn't have no bias. So like it's not like I have the coin set such that, you know, every time you flip it, it gets a head, or every time you flip it, you get a tail. So unweighted in this case is the same thing as if I had said fair. Okay, a fair coin. So everything is fair about this. Each outcome is equally likely of happening. All right, so if they say unweighted coin, fair coin, or just coin itself, they typically mean the same thing. So so don't hurt yourself with that word unweighted. Okay, good. So let me have we'll be looking at sample space, right? What's my sample space? Albanic.
Heads and tails.
Say it again.
Heads and tails.
Heads and tails. The set that contains heads and tails. The set that contains heads and tails. So that would essentially be this. All right. Exactly what we have for this one. The set that contains heads and tails, so it's gonna be voila. Good. Very good. And then outcome sample space. Then we need the number of elements in the sample space. So Altonic, what is the number of elements in the sample space? Let's go Altonic. What is the number of elements in the sample space? Altonic, you're not there? Oh. I guess I'll go with,
Saying two.
oh, two. Very good. Okay, good. Two. All right, very good. Two. So number of elements in our sample space for that one is going to be 2. Sorry. Good. So that's the answer for number 1. Now let's do number 2. So number 2, so let's move on. It's supposed to be number 2. Voila. Okay, number 2. So the next one, it says casting an unweighted dice and observing the numbers face up. So Sierra, outcomes.
Okay, so the outcomes is 1,
Just give me it all.
2, 3, 4, 5, 6.
Very good. 6. What's my number of elements in my sample space?
1, 2, 3, 4, 5, 6.
Very good. And what is sorry, Rashan, what is going to be my number of elements in the sample space? Rashan.
6.
Very good. I was wondering if you were there. I was like, did we lose Rashan or what? All right, 6. All right, next up is, this one is for Miss Johnson, sorry. So choosing at random a letter from the word Caleb. So what is going to be my outcomes, Miss Johnson?
1, 2, 3, 4, 5.
Remember, be careful now. We're choosing a letter from the word Caleb. So be careful. So it's going to be my outcomes. What letters I could choose from?
CALEB.
Very good. C, A, L, E, and B. The sample space is gonna be what, Miss Johnson?
S equals CALEB.
Very good. S equals that's set, so we have to use set notation. So curly brackets and all. So C, A, L, E, and B. Good. And then the number of elements in that in the sample space, Miss Johnson, is gonna be what?
5.
1, 2, 3, 4, 5. Very good. 5. Good. Now the next one is choosing at random a whole number from 1 to 8. So Casey, what's gonna be my outcomes? I want a whole number from 1 to 8.
1,
Yeah, 1. What else?
2,
Uh-huh.
3,
Yes.
4,
Yes.
5, 6, 7, 8.
Very good. 5, 6, 7, and 8. Then you have sample space, which is, oh, I forgot. So sample space is going to be the set that contains these numbers. So 1, 2, 3, 4, 5, 6, 7, and 8. And then what's going to be the number of elements in my sample space? Casey.
8.
8. Very good. 8. All right, excellent. Now Jasmine asked to do number 4. So you let her do that. What's going to be my outcomes, Jasmine? I want prime numbers from 2 to 7. Where's Jasmine? Hello, Jasmine. She asked to do number 4 and I don't see her.
Can I do it?
Got it.
Okay, go ahead, Jasmine. What are the outcomes for choosing at random numbers, prime numbers from 2 to 7? Say it again.
I thought I was on 2,
Go ahead.
3,
Yes.
5, 7,
7.
7,
11. Yes.
13,
13. Yes, ma'am.
17,
17. Very good. What's gonna be my sample space?
2,
So
3.
yes. So everything that was inside it, but only thing curly brackets, right? Can't forget that.
Yes.
All right. Good. And then what's going to be the number of elements in my sample
7.
space? 7. So 1, 2, 3, 4, 5, 6, 7. Yes. 7. 7. There we go. And then we have question number 5. Okay, good. This one is for Deja. It's going to be my outcomes.
I have pear, apple, orange, banana, peach, and mango.
Because all of those are different fruits that I could choose from. Good. What's going to be my sample space?
S equals the curly bracket.
Sorry, let me get this together. Go ahead. So it's going to be, finish it for me. S equals what?
Curly bracket, pear, apple, orange, banana, peach, and mango.
Very
Same thing
good.
in outcome.
Same thing in outcomes, just with the, just putting them in a set, right? And then what's going to be the number of elements in my sample space?
6. Oh no. And put S in parentheses and then equals 6.
1, 2, 3, 4, 5, and 6. So it's going to be 6 indeed. All right, so those are our answers. Any 5 out of 5? 4 out of 5?
Excuse me, I have a
5 out of
question.
5.
4 out of 5.
Okay.
Question.
Go ahead.
All of them.
Okay.
So like for the numbers one, right? Where you say choosing at random, you can like put down the numbers for the outcomes like in random.
Oh, you mean like it don't have to be in this particular order?
Yes, sir.
I mean, once the numbers are there, okay? So if you have the 2 and the 3 and the 5 and the 7, the 11, the 13 and the 17, even though they may not be in the same order, but once they're there, okay? That's important. Okay, so that's what we mean when we say um, experiment, right? Sample space, outcomes, and number of elements in the sample space, right? Wow, I feel like we got smarter. We now know what we mean by experiment in math. What do we mean by sample space in math? What do we mean by outcomes in math? And we know in a technical way what these things mean, right? So that's good. So that's a level up. So let's continue. So, all right, let's put this here. Where can we put it? Let's put it. Voila. All right. All right. Good. All right. I guess that stays. Okay. What else we need to? Okay. So that's experiments, outcomes, and sample space. I want to introduce because we only have a few moments left. I'm not going to introduce another term, but there is something that we can look at. Another sample space that we can look at that is going to be useful and going to be helpful as we continue on with our discussion. So one of those sample space that we really haven't even looked at the sample space, in this whole discussion is what happens when I have, so let's look at the sample space, and I think this is going to be probably it for math. That's if, we still have more time. We don't have enough time though. And I think for the sample space, I'm going to need to use the PowerPoint. And it's going to be an interesting sample space once you see it, right? So let's look at the sample space. So first I'm gonna I'm gonna give you the experiment. So let's say the experiment, right? So construct a sample space for the following experiment. So let's say your experiment is that you cast 2, and I put 2 in brackets, indistinguishable dice and observe the numbers facing up. So that's very important. So we have 2 indistinguishable dice that we are casting, and of course we're doing them at the same time. The question is, what is going to be our outcomes? What's going to be our sample space? What's going to be our experiment? So let's deal with the experiment the sample space first. So let's look at this. So if I am going to cast, remember now, I'm going to cast 2 indistinguishable dice. Now when I say indistinguishable, Anyone know what I mean when I say indistinguishable? Deja, what do I mean by indistinguishable?
Well, I guess distinguishable means you could tell the difference. So indistinguishable means you can't tell the difference.
Yeah, indistinguishable means you can't tell the difference. Let's use the distinguishable first. So, or let's look at that because that one is what I really want to look at first. So, let's say you can't tell the difference. So you can tell the difference. So you can tell the difference between these two dice, right? So you can tell the difference. The difference is clear between them, right? So reason why you want that is because something important is gonna happen. So the difference between them is clear. So let's say one is a red dice. Say one is a red die, right? And let's say that the other one is, say, a blue die. So a blue dice. So you can tell them apart clearly. One is red, one is blue. So these dice are distinguishable from each other. I can tell them apart. Right? What's gonna be my sample space? And first of all, how much outcomes I'm actually gonna have? Like, that's an interesting question, right? Like, what exactly is gonna happen now? Right? So let's look at it, right? So if we have this sample space, and first of all, let me just ask you all before I venture on and say, how many outcomes you think I can get with these two dice? How many outcomes you think I could get with these two dice? Remember, it's no longer one dice. Remember, with one dice, how much outcomes we could get with one dice?
Well,
With one dice,
that's right.
with one dice, how much outcomes we could get with one dice? Number
6
six. Yes, 6. Very
and
good.
2 is 12.
So since I have two dice, how much outcomes do you think I'm gonna be able to get?
12.
Say 12. Okay, anyone else? Sierra, Deja, Dylan. What outcomes do you think? How much number of outcomes do you think I'm gonna be able to get with? I have two dice now. I don't just have one.
1, 2, 3, 4, 5.
Okay, 1, 2, 3, 4, 5. What did you say, Jasmine?
Same thing you just say. I don't know. I just got.
You just guessed it. Anyone else? Deja, Sierra, Dylan, Deshawn.
I'm thinking the same thing, but I'm not sure.
When you say same thing, what you
Yeah.
mean?
I mean, like, if one could give you 6 and the other one give you another 6, then together that'd be 12. That's what
Together
I'm
that'd be
thinking.
12.
Too.
Okay, interesting. Sierra, what you think?
It's 12.
Set them right, Sierra. Set them right. You think it's 12 too? Oh, Sierra agreed with you all.
I think it's 12.
You think it's 12? Okay.
No,
Okay.
but okay. If red is 6 and blue is 6, it'll be 6. right?
It'll be 6. Okay. All right. Well, maybe Miss Johnson have an answer for us. Maybe she could set us right. So, Miss Johnson, what you think? Where's Miss Johnson? She's in there anymore? I promise I just saw her. Okay, she probably left. Rashan, what do you think?
I really have no clue.
She says you really have no clue. All right.
Oh, wait a minute. I mean, okay.
Ah?
Ask if it's 9 or 3.
9 or 3. Okay, so we have one of the albums.
Wait, I want to say something.
Go ahead.
I'm not sure because what if you shake the 2 dice and then throw them both land on 6?
Uh-huh.
So wouldn't that be 12? I don't know.
Ah, y'all are funny. Okay, so let's actually do the sample space together, right? Maybe that'll help. So remember, the sample space is going to contain all of our possible outcomes. So I'm going to have this big. That's probably a bad way to put it. So let's again, they have a curly brackets, but this curly bracket is going to be bigger than usual. Good. So let's begin with the first possibility. So it's possible for this red dice to land on 1, right? And for the blue dice to land on 1. That's perfectly true. So that's one option. It's also possible for the first one to land on 1 and the second one to land on 2. So that's 1 and 2. It's also possible for the first dice to land on 1 and the second dice to land on 3. So this dice fall on 1 and this one fall on 3. It's also possible for the first dice to land on 1 and the second dice to land on 4. So that's 1 here and then 4 there. It's also possible for the first dice to land on 1 and the second dice to land on 5. So that's 1, 5. Also possible for the first dice to land on 1 and the second dice to land on 6. Is that possible? Hello? Mic test 1, 2.
Mm.
Testing, testing, 1, 2, 1, 2. Yes,
Yeah,
sir. We hear you.
yeah. You hear me? Okay. Good. Any questions on what we just did?
So it would just be 6 then?
We're not done. It's possible for the second dice to land on 2. The first dice to land on 2 and the second one to land on 1. It's also quite possible for the first one to land on 2 and the second one to land on 2 as well. So both of them land on 2. It's also possible for the first one to land on 2 and the second one to land on 3. Similarly, it's also possible for the first one to land on 2, the second one to land on 4. It's also possible for the first one to land on 2 and the second one to land on 5. And it's equally possible for the first one to land on 2 and the second one to land on 6. Good. Are we done?
Nah.
Nah. All right, so what next? Someone help me with the next row. Who can help me with the next row?
3, comma 1.
Okay, so we could have the first one land on 3 and the second dice land on 1. Okay, what else?
3, 2.
3, 2, very good.
3, 3.
3, 3, so both of them land on 3. The first dice
3,
could land on, 3 what?
4.
Very good. So next
3,
one. 3, what?
5.
And then last one is
3, 6.
3, 6. All right, so Deja, is it still 12?
No, so which I was speculative of at the beginning.
Ah?
So that means it could land on 6, 6.
Yes, it could land on 6, 6. That's a possibility. So help me out with the next option, Deja. What we have? The next row. I mean the next column, sorry.
Okay, so first dice land on 4.
Uh-huh.
The other one lands on 1.
Uh-huh.
Yeah, I think it says 4. So the first dice will stay on 4, and the
Mm-hmm.
other dice will land on 2.
Mm-hmm.
First dice will land on 4.
Yeah.
Other one will land on 3.
Yes.
First dice on 4, the other one on 4.
Mm-hmm.
First dice on 4, the other one on 5.
Mm-hmm.
And first dice on 4, the other one on 6.
Very good. Good. Sierra, help me with the next row.
Okay.
Go ahead.
Okay. 5 and 1.
5 and 1.
5 and 2.
Uh-huh. 5 and
5 and 3. 5 and 4. 5 and 5. And 5 and 6.
excellent. So the first one land on 5. The second one land on 3. The first one land on 5. The second one land on 4. The first one lands on 5, and the second dice land on 5. The first one land on 5. The second one land on 6. All right, Miss Johnson, Deshaun, sorry, uh, Miss Johnson, what's the next option that we have for the next column? Miss Johnson, are you here? I'm not hearing from us, so let's go, Jasmine.
Okay. 6 1.
6 1,
6 2.
6 2,
6 3.
6 3,
6 4.
6 4,
6 5.
6 5,
And 6 6.
6 5, and 6 6. Okay, Deshaun, can you help me with the next column?
7 1.
Okay, all right. Think about this column. Is it possible for the first one to land on 7?
It is impossible. I don't think so.
Me neither.
It is impossible.
It's not possible?
Unless the dice have 7 on it.
How much sides does the dice have? Only what?
8.
Only 6. So this is not possible. Okay. So sorry, Deshaun, kind of put you into the trap. It's not
That's
possible.
okay.
It's
I'm
not.
learning.
Yeah, it's not possible for that, right? We stop at 6. Okay. So I want some brave soldier to tell me what's the total possibility, or what's the not total possibility, but the total number of outcomes. Uh-huh.
6.
Not 6. What's the number of outcomes in S? What's the number of outcomes in S?
2 and 2.
Mm-mm.
1.
Mm-mm. The total number of outcomes in S. Count all of them that's inside there. How much elements do we see inside there?
36.
36. Very good. 36. If it's counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, excuse me, 31, 32, 33, 34, 35, 36. Very good. So it's 36. So the number of elements inside this sample space is 36. That means that there are 36 possible outcomes if you have 2 dice and you're rolling them at the same time. Okay. All right, so that brings us to the end of math, unfortunately. We learned a lot of things today. I hope it was of interest to you. If we learned a lot of different sample spaces and different experiments that could happen, what I mean by outcomes and the like. And so that brings us to the end of math. I'm not going to prolong that. Let's move on to English. Remember, for those of you who are delinquent in sending your notes, remember that I want you to send your notes right after class. So please don't have me have to run after you for notes. And don't send it the next day, like the night of, please. So send your notes right when we are done, so that I can have them and know that you're following along. All right. Okay, so then there's that. I think that we are ready to begin English. The last thing we're doing in English, anyone could remember?
It is about
The
capitalizing.
capitalization
Within
rules. Very good. We're looking at capitalization rules extensively, looking at that, and we looked a lot at those capitalization rules and figuring out, exactly what I trying to figure which capitalization rule did we end with. Which one did we end with last week?
The rule that says that we should capitalize holidays, months, and special days.
Okay. So let's pull out that file. Thank you. By the way, let me just save this one time so I wouldn't have the hassle of. So anyone liking probability so far, or it's a hassle?
I like it.
Okay. All right. Anyone else other than Jasmine?
If you want to.
I like it.
Okay. For starters, okay. Okay.
I'm just amicable with it. It's
You
not
like
that I hate or I like it. I'm just friendly with it.
you are?
It's one of them problems that you would like to solve.
It's not okay. One of the problems that you like that. Okay. Probability part. So what we do this is what sample spaces and events. All right, part 1. Most teachers don't teach probability like this. They don't go through these details like that, because we haven't really even gotten into a definition of probability yet. We've just looked at sample space, events, and number of elements in sample space. Then we'll use our knowledge of this to answer probability questions. That should be nice. And yeah, so this is good. This is good. Good foundation for you. Very good foundation, I'd say, with this topic. I like stuff like this. So let's look at capitalization rules. All right. Capitalize the first letter in the first word of a sentence. Capitalize the pronoun I. Capitalize the first letter in most lines of poetry. Capitalize the first word and the last word of all important words in any title, and then capitalize people's names, their initials. We looked at George Bush, Mother Butler, Dame Ivy Dumont. And the last thing we on was capitalizing important special days, and holidays. So that's what we That's the last thing that we did. So today we continue in that journey of capitalization rules. We still have some more to go. And if we have enough time, we could actually get into something else. I want to make the, so let's, okay, so let's look at that. So let's head up properly for English. Today is what? Tuesday, the 11th, right? So, yes, ma'am,
The
Tuesday.
second.
The second. Sorry, I just was testing y'all, making sure y'all, up to date. Sorry about that. I genuinely made an error. Okay, so subject is, I know y'all wanted to say mathematics, but that's fine. We're doing English today. The topic is going to be capitalization rules continues, right? So hopefully you're not just learning these capitalization rules and you'll be like, putting them in the back burner, but hopefully you can look at your own writing and say, you know what? I wonder did I capitalize everybody's name, and their initials. I wonder, when I use the title of a book or title of an article, did I capitalize the first word and the last word and the special words? I wonder, did I capitalize the pronoun I even when I'm using stuff like am or I'll, capitalize them still, capitalize I still. Did I capitalize every sentence? Um, you have persons who would write an essay and their sentences, the first letter, their first word is not capitalized. That's not right. When you beginning sentences. So, hopefully you just not just learning these, but you like, trying to see how you can implement it in your own writing, helping you with not to make those mistakes. All right, so capitalization. Oh, sorry. Okay in that. All right, capitalization rules. All right. Continued. All right, so this one you may know, and this is what the seventh one. So you want to capitalize the names of organizations. Okay. So if you have an organization that is something that you're trying to write on, you're going to capitalize it. So capitalize the names of organizations. So please write this down for me, please. So, for example, excuse me. For example, if we have, say, Boy Scouts, Boy Scouts of America. I don't know if you're familiar with that particular organization, but it's one of those organizations that are known. Anyone ever heard about Boy Scouts?
Yes, sir.
Yeah,
Yes, so like Girl Guides.
yeah. So obviously this is the wrong way to write it. So how would I fix it, Deshaun? Okay, he's not here. Dylan, how would I fix it? Boy Scouts of America.
Capitalize the B in boy.
Yes, sir. Can't forget the S in Scouts. We do not capitalize the of because of is not important. And then America. So this is going to be the right way to do it. Good. Next up, what if we have, say, say we have the Bahamas. Red Cross. Anyone ever heard about the Red Cross before?
Yes,
Yes,
sir.
What do they do?
like
Um,
a hurricane.
they help people charity.
Yeah, charity. In case of hurricane, they try to provide relief and stuff like that. It's a good place to volunteer, you know, to help out. Very good thing to do. How are we gonna fix this? Sierra.
Capitalize the B in Bahamas, R in red, and C in cross.
Very good. R in red and C in cross. So you want to capitalize those names of those organizations properly. So those are some examples there. I think we get the picture. Fine, let me just use one more example, and then we can move from this. If we have the North Atlantic Treaty Treaty Organization. Jasmine, how do we deal with that?
The N in North,
Mm-hmm.
the A in Atlantic,
Yes, ma'am.
the T in treaty,
Yes, ma'am.
and the O in organization.
Very good.
Okay.
And the O in organization. Very good. So wrong and right. Okay. Good. The next thing is that we want to do is we want to capitalize. This is number 8. Capitalize the names of institutions. Okay. So if you're trying to put your school name in in writing, you have to capitalize it. So for example, A dot F AF Adderley. Anyone ever went to AF Adderley? Or know someone who's go to AF Adderley?
Oh, I know someone.
Okay. Yeah.
They're my
Yeah,
neighbors, so
my father used to go there.
Oh, your dad. Okay. Yeah, I actually went to AF Adderley. Interestingly enough. Um, that was those were the days, right? Those were the days. All right, so AF Adderley Junior High School. So how would we write this, right? How would we? Obviously, this is the
The
wrong.
A and F.
Okay, so we have already.
The A and A Academy.
That's true. I just catch on what you say. Where do we get it? The A. What else?
The F.
Okay, the F. So let me make this more visible. So the A. The F.
The A in Adelaide.
The A in Adderley. Very good.
The J in Junior.
The J in Junior.
The H in High.
The H in High.
And the S in School.
And the S in School. AF Adelaide Junior High School. Very good. This is the correct way to represent that. Oh, no. I want to correct that. So, why is this becoming so problematic? I just see what that is. Okay, good. So that's wrong, but this is the right way. All right. Anyone want to use their school?
I'm Ellen Coakley High School.
Ellen, what it is?
Ellen Cook. No, just put L.
Oh, L N. Okay, cool. L.
And Coakley High School.
Okay. So it's what? It's a junior, senior, or just high school?
Junior.
Okay.
No, wait. High school is high school.
This high school. Y'all go up to what grade?
Well,
Y'all go up to grade 12. Okay. All right. I guess it's junior through senior. Okay, good. So how are we gonna correct this?
who?
So you put the L in, capitalize the L, definitely capitalize the N, definitely capitalize the C, Coakley High School. Okay, so this is going to be the right way to represent that school. So it's right. This is going to be the wrong way. Okay, so then there's that. So we're going to capitalize the name of institutions. That's important. That was the 8th one or the 9th one? 7th. Oh, there's one more we could use before we so university. I want to use like something that you would say use. So Princess Margaret Hospital. Oops, I do it. So obviously this is the wrong way to do it. You don't want to put, I spelled Margaret wrong. Oh, they obviously they wanted me to capitalize that. Obviously the P in princess, the M in Margaret, and the H in hospital. Good. That's right. Okay, the next thing we're going to do is we're going to capitalize business names. Oh, there's an I. Okay. Capitalize business names. Why is this 9? Isn't it supposed to be 10? Interesting. Well, this is 1, 2, 3, 4, 5, 6, 7. Okay, 8, 9. All right. Capitalize business names. So obviously, a business could, so let's see examples. So examples would be, say, Delta, Airlines. Anyone know what Delta Airlines is? Or heard about Delta Airlines?
Yes, sir.
Okay. Anyone ever rode on or flew on Delta Airlines?
No, sir.
No. Wow. Yeah, Delta. That's one of those flagship airline companies. Trying to go to the States or Atlanta or whatever. You go on Delta. Okay, so you've got obviously capital DELTA, airlines with the capital A, and that's how we correct it. So Delta Airlines is going to have to be capitalized. Another one is Holiday Inn. Anyone ever heard about Holiday Inn before?
Yes, sir.
Okay. So Holiday Inn, that's the wrong way to do it. Capital HLDA. Holiday Inn, that's the right way. So this is going to be the wrong way. And this one is the right way. Good. Capitalize business names. Even say a name of a restaurant. So if we have Posada restaurant, obviously capitalize the P in Posada and the R in restaurant. So obviously this is going to be the wrong way on top, and the right way is going to be at the bottom. All right, so you capitalize business names. Okay, I'm gonna end there. I don't want to prolong it anymore. So send me those notes. We still have a few more of these. Well, not a few more, sorry. Good much. Hopefully we could finish this week. And but send me the notes on in English.
Send the math and English back.
Send both, please.
Okay.
The math and the English. And I'll see you on tomorrow, day 3. Remember class start at 6 o'clock on tomorrow. Try to be on time so that we can have a good start or early start. Once again, have a wonderful night and take care.